Welcome to Cloud Computing with Typical Monk, Class 1. What is cloud computing? For most of computing history, running software meant owning the machines. If you wanted to launch a website or an app, you first bought physical servers, rented space in a data center, paid for power and cooling, and hired people to keep it all alive months before a single user arrived. And you had to make an almost impossible bet. Guess your busiest moment years in advance. Buy too much, an expensive machine sat idle, burning money. Buy too little, and your service collapsed on the one day it mattered most. Cloud computing tears up that bet completely. Instead of owning computers, you rent them. Compute power, storage, databases, networking, and hundreds of ready-made services on demand over the internet, and you pay only for what you actually use, measured to the second and the gigabyte. It is the same shift the world once made with electricity. You stopped running your own noisy generator and simply drew power from the grid, paying for the units you burned. Amazon Web Services opened this world to everyone in 2006, and today, the cloud is where new software is built by default. From a two-person startup to the largest bank. Over this course, we will travel from these first principles all the way to the Amazon Web Services Cloud Practitioner and Solutions Architect certifications, and into modern AI in Hindi and English together. Today we lay the foundation stone, what cloud computing truly is and why it changed everything. One idea at a time. Before we dive in, here is the map of today's journey. 6 ideas that together answer one deceptively simple question. What is the cloud really? First, on-premises versus cloud. The old world of owning servers set against the new world of renting them. So you feel exactly what changed. Second, the 6 advantages of cloud. The concrete, hard-nosed reasons the whole industry is moving, not hype but economics. Third, elasticity versus scalability. 2 words that sound like twins but mean very different things, and confusing them is the classic beginner mistake. Fourth, the 5 NIST characteristics. The formal, official definition, so you can say precisely when something is a cloud and when it is not. Fifth, the providers and the core services. Who actually offers the cloud and what you can really run on it. And 6, the course roadmap. Exactly where this journey carries you, from your first certification to designing real systems. One idea at a time. Let us start with the world before the cloud, placed side by side with the world after it. Because you cannot appreciate the cloud until you feel the pain it removes. On the left is on-premises, the traditional way, and for decades the only way. Here you buy everything yourself. The physical servers, the racks they bolt into, the industrial cooling that stops them melting, the backup power for when the grid fails, and a team of people to run it all. Every bit of that is a huge upfront cost, capital expenditure, or CapEx, spent months before your first customer arrives. And here is the cruel part. Because ordering and installing a server takes weeks, you must decide your capacity in advance, almost blind. Guess too high, and you have paid for rows of machines that sit idle most of the time. Guess too low, and on your busiest day, the site slows to a crawl and crashes, losing you the very customers you worked hardest to win. On the right is the cloud, and the whole equation flips. There is no upfront purchase and no data center to build. Capacity behaves like a water tap. You open it when you need more, close it when you need less, and it responds in minutes, not weeks. When traffic surges, more servers appear automatically. When it fades, they quietly disappear, and you stop paying for them. You are billed only for what actually ran. Strip it down to 3 words, and the entire revolution is this. You go from own to rent. Ownership becomes access. You no longer buy the whole cow to get a glass of milk. So the takeaway, the cloud turns computing into a utility. You stop gambling on capacity, you must guess months ahead, and start paying only for what you truly use, with capacity quietly following your demand up and down. Now the single trait that defines the cloud, and the pair of words people most often confuse. Look at this one graph. Time runs along the bottom, and the amount of capacity you have runs up the side. The dashed blue curve is demand, the real load your users put on the system. It is never flat. Think of a shopping site that dozes at 3 in the morning, climbs through the day, and then explodes during a festival sale. Demand rises, spikes, and falls, hour by hour. The pink step line is scalability. Scalability is simply your ability to add capacity when you need more. But notice the shape, it moves in deliberate planned jumps. A human decides to add servers, orders them, and provisions them ahead of time. It is powerful and it is necessary, but it is manual and it is planned in advance. On its own, it still leaves you guessing. The green curve is elasticity, and this is the cloud's superpower. Elasticity is the system doing that work for you, automatically and in real time. Adding capacity the instant demand climbs, and releasing it the moment demand drops. Set a rule like keep each server under 70% busy, and the cloud spins new servers up and tears them down on its own, all night with nobody watching. You are never paying for idle machines and never caught short in a surge. So the takeaway, scalability is planned capacity you add in steps, elasticity is automatic capacity that follows demand on its own in real time. Every serious cloud system is built on that second idea, and mixing the two up is the classic beginner slip. So why is the entire industry moving to the cloud? This is not fashion, it is economics, and Amazon Web Services frames it as 6 concrete advantages. Let us take them 2 at a time and really understand each. First, cost. You trade capital expense for variable expense. Instead of a giant upfront purchase that sits on your books for years, you pay a small amount for what you use and stop paying the moment you stop. And scale. Because a provider serves millions of customers on shared hardware, it buys power and equipment at a scale no single company could and passes those lower prices to you. You inherit economies of scale you could never reach alone. Next, capacity. You stop guessing. You no longer forecast demand years ahead and pray, because you can add or release capacity in minutes as reality unfolds. And speed or agility. Resources that once took weeks of purchase orders now appear in a few clicks. So an idea can become a running experiment the same afternoon, and your teams simply move faster. Then upkeep. You stop pouring money and attention into running data centers. The racking, the power, the cooling, the physical security, the failed disk at 2 in the morning are all the provider's problem now, freeing your people to build product instead. And global reach. With a few clicks you deploy your application into data centers on the far side of the planet, so a user in another country gets the same fast experience. Something that once meant years and millions to build. So the takeaway, cost, scale, capacity, speed, upkeep, and global reach, 6 advantages, and every single one of them flows from the same 2 roots, pay-as-you-go pricing and enormous shared global scale. We have a strong intuition now. Let us make it precise, so you can define the cloud with authority. The American National Institute of Standards and Technology, NIST, wrote the definition the whole industry agrees on. A system is truly a cloud only if it shows 5 essential characteristics. The first 2 are about access. On-demand self-service means you provision what you need yourself instantly through a console or an API. No phone call, no ticket, no waiting days for a human to approve it. And broad network access means you can reach that capability from anywhere, over the ordinary network, on a laptop, or a phone. Together they mean help yourself from anywhere, right now. The next 2 are about the engine underneath. Resource pooling means the provider runs one enormous, shared, multi-tenant pool of hardware and hands out slices of it to many customers at once. Your virtual server and a stranger's may sit on the very same physical machine, safely isolated. That sharing is exactly what makes it cheap. And rapid elasticity. The idea we just met means the pool grows and shrinks for you automatically. And the 5th characteristic ties it all together. Measured service means everything is metered. Compute time, storage, data transfer, and you are billed precisely for what you consumed. Exactly like an electricity meter ticking in your home. No metering, no cloud. So the takeaway, on-demand self-service, broad network access, resource pooling, rapid elasticity, and measured service. Hold them like a checklist. If all 5 are present, it is a cloud. If even one is missing, whatever it is not. So who actually provides all this power? And why does this course choose the one it does? The cloud is offered by a handful of giant companies we call hyperscalers, and understanding the landscape helps you see why we start where we start. The clear leader is Amazon Web Services. It launched first back in 2006, so it has the longest head start. It offers the widest catalog of services by far, and it holds the largest share of the market, which means the most jobs, the most tutorials, and the most demand for the skill. That is precisely why this course focuses on Amazon Web Services. You learn the platform employers ask for most, and the core concepts you gain transfer to any cloud. The strong second is Microsoft Azure. Azure runs especially deep inside large enterprises that already live on Microsoft software, Windows, Office, and the rest. So if you walk into a big corporate department, you will meet Azure constantly. The ideas are the same. The names on the buttons differ. Third is Google Cloud, respected above all for data, analytics, and machine learning, and often chosen by teams whose product is built around those strengths. And beyond the big 3 sit others: Oracle, IBM, Alibaba, and more, each defending its own niche. So the takeaway: there are several clouds, but Amazon Web Services leads the field. So we learn Amazon Web Services first, confident that once you understand one cloud deeply, you can step onto any of the others. And what can you actually run on a cloud like Amazon Web Services? Almost anything a computer can do. But the hundreds of services become far less intimidating once you group them into a few core categories, each answering a basic need. The first 2 are the bedrock of every application. Compute is rented processing power. Servers you switch on in minutes, run your code on, and switch off. On Amazon Web Services, the classic service is EC2, and it is the workhorse that actually runs your program. And storage is a place to keep files and data that grows without limit and never fills up. The famous one is S3, where a startup and a giant alike keep their images, backups, and logs. The next 2 connect and organize. Databases give you managed home for structured data, orders, users, payments, without you babysitting the server, patching it, or backing it up by hand. A service like RDS does that heavy lifting for you. And networking lets you carve out your own private, walled-off network inside the cloud, controlling exactly what can talk to what. On Amazon Web Services, that is the VPC, your own secure neighborhood in a shared city. And the last 2 turn raw data into value. Analytics services let you ask questions of enormous datasets, millions of rows, and get answers in seconds instead of days. Athena is one example. And AI and machine learning services like Bedrock let you add generative AI to your own application through a simple call without owning a single GPU or training a model from scratch. So the takeaway: compute, storage, databases, networking, analytics, and AI, whatever the workload, the cloud already offers it as a ready-made, rentable service. So you spend your time assembling an application instead of building the infrastructure beneath it. It helps to see how we got here, because this whole world is more recent than most people realize. Follow the timeline. In 2006, Amazon Web Services launched with just 3 services: S3 for storage, EC2 for compute, and SQS for passing messages between programs. It sounds humble, but the effect was revolutionary. For the first time, any developer anywhere with nothing but a credit card could rent the same world-class infrastructure that once only tech giants could afford, and pay by the hour. The barrier to building something big simply fell away. Through the 2010s, the hyperscalers grew explosively. Microsoft launched Azure, and Google launched Google Cloud. Competition drove prices down and features up. The catalog swelled from 3 services into hundreds. And a whole generation of startups, the apps on your phone right now, were built entirely in the cloud, owning no servers at all. Then, the cloud crossed into the mainstream of serious institutions. Banks, governments, and hospitals moved their systems in. and today it carries the wave of generative AI through services like Bedrock and Q on Amazon Web Services that put powerful models one API call away. So the takeaway, in under 2 decades, the cloud went from 3 small services to the default home of computing, which is exactly why knowing it is now a foundational career skill, not a niche specialty. So where will this course carry you? Let us look at the whole path at once, because every single class we do fits somewhere on it. We begin with the Amazon Web Services Cloud Practitioner Certification, code CLFC02. This is the foundation. What the cloud is, how identity and security work through IAM, how pricing and billing work, and the core services and their vocabulary. It is the level that makes you fluent, able to sit in any cloud conversation, and follow every word. Then, we step up to the Solutions Architect Associate, code SAA-CO3, the certification employers prize most for cloud roles. Here you stop naming services and start designing systems, choosing the right compute and storage for a job, building secure networks with the VPC, picking the right database, and applying the well-architected framework so your designs are reliable, secure, and cost-effective under real pressure. And we finish in the present day, modern generative AI on Amazon Web Services, plus a capstone project where you design something end-to-end with your own hands, using the free hands-on lab environment that comes with this course, so the knowledge lands in your fingers, not just your notes. So the takeaway, our road runs from cloud practitioner to solutions architect to modern AI, turning you, step by patient step, from someone who has merely heard of the cloud into someone who can confidently build on it. Let us gather the whole class in one breath so it locks into memory. The cloud is on-demand computing you rent over the internet and pay for as you use it. Computing delivered as a utility, like electricity from a grid. It brings 6 hard advantages. CapEx becomes variable cost. You gain economies of scale. You stop guessing capacity. You move with agility. You drop the whole burden of data centers, and you reach the entire globe in minutes. Elasticity, which is automatic and real-time, is not the same as scalability, which is planned and manual. Remember that difference. It is the classic trap. NIST defines the cloud by 5 essential characteristics: on-demand self-service, broad network access, resource pooling, rapid elasticity, and measured service, all 5, or it is not a cloud. 3 big providers lead, with Amazon Web Services in front, and they offer everything: compute, storage, databases, and much more as ready-made services you simply rent. And all of this began in just 2006 and has already become the default way new software is built. Next class, we go one level deeper. The service and deployment models, IaaS, PaaS, and SaaS, and public, private, and hybrid clouds. One idea at a time. The utility of our age. Cloud computing did to information technology what the power grid did to electricity. It turned something you once had to build, own, and babysit into something you simply switch on and pay for by the SIP. That one shift, from capital expense to variable expense, from fixed capacity to elastic capacity, is what makes the cloud fast, global, and genuinely affordable. And it is captured perfectly in those 5 NIST characteristics we will keep returning to. From here, we build steadily and patiently toward the Amazon Web Services certifications, and toward something more valuable still: the ability to design real systems of your own, with confidence. Next class, the service and deployment models, the very next layer of the foundation. One idea at a time. Welcome to the cloud.